Hi, I'm just going to talk through these questions on constant angular velocity, which you could do once you've watched my two videos on the introduction to rotational motion. So I'll read through the questions and I'll talk you through the answers. So when starting an outboard motor, the cord of length 0.50 meters is pulled such that it travels at constant speed while it's unwinding off the spool. The radius of the spool is 0.10 meters and it takes 0.50 seconds to be pulled off. Now, question is use d equals v times t to calculate the speed of the cord as it's being pulled off the cord. So v is d over t, or v is equal to your distance is 0.5 meters, time is 0.50 seconds, so your speed is 1.0 meters per second. And then the other one is to calculate the angular speed. So the connection between linear speed and angular speed is v equals r omega, where r is the radius, or omega, our angular speed, is v divided by r. So we just calculated the velocity to be 1. The radius is 0.10 meters. So when you divide that, you get the angular speed, which is in radians per second. Okay, then the next question is a ball is rotating at a speed of 3 revolutions per second at the end of a cord of length 1.5 meters. Now this 3 revolutions per second is actually frequency. How many times something goes around in 1 second? So it does 3 whole revolutions in 1 second. So you got to recognize anything given as revs per second denotes frequency. So the first thing we have to do is calculate angular velocity and then do period. I just did it an easy way. So angular velocity or angular speed is omega is 2 pi f. So this is something that will be given to you. So 2 pi times frequency, you get the answer. How do you get the period? You can also do omega is 2 pi over t, and then you can use that to get t, or also there's a connection between t and f. T is 1 over f. So I just do 1 over f in order to get t straight away. And then it says calculate the orbital speed. Now orbital speed has to do with the linear speed. So speed at a particular point on a revolving object, that is your linear speed. Okay, so v equals r omega. You got omega, multiply by r, and you can get the speed. Okay, and that's in meters per second. If they say angular speed or angular velocity, that's your radians per second. Okay, then question 3. A record on a turntable rotates at a constant 33 revs per minute. At the beginning of the recording, the needle is 15 centimeters from the turntable axis, and at the end, the needle is 5 centimeters from the axis. Now, you may not have seen a record in a turntable. Those were things years and years ago, but I've drawn a picture. So this is something that's spinning around, and in order to listen to music, you had to have this little needle. And what actually happens is this record actually has grooves, concentric grooves all around, and the needle kind of goes along the grooves at the start, and at the end it's somewhere over here. So at the start of the playing the music, whatever, it's 15 centimeters from the radius, and at the end, when you come to the end of the song, it's kind of gone through, it's only 5 centimeters from the radius. So that's what it means. So just like I said, revolutions per second is frequency. Revolutions per minute also indicates frequency, but we need to change the per minute to per second. So question A is calculate the angular speed of the record. Now angular speed is omega is 2 pi f, but we need the f to be revolutions per second. So what we do is f is 33 revs per minute. That means 33 revolutions in 1 minute. So revolutions, you keep it as it is, but minute is 60 seconds. So 33 divided by 60, you get 0.55. So now you know your f. Now in order to get omega, you just do 2 pi f, multiply that, you get the answer. And then B is what's the linear speed at the beginning of recording? V is r omega, but at the beginning your radius, this is your radius is 15 centimeters. So you got your omega, this is angular velocity, multiplied by 0.15, you get the answer, and then the linear speed at the end, you get a new radius times the same angular frequency or angular velocity, and you get the answer. Okay, question number 4, I had to move on to this page. It is about a winch that is pulling up a boat anchor from a depth of 31 meters. It rotates at 1.2 revs per second, and the rope is winding onto a spool of radius 25 centimeters. So I kind of tried to draw the diagram for you here. So that's a winch which is kind of turning this way, and so it's pulling the anchor up. Okay, so first of all, you got to recognize the 1.2 revs per second indicates frequency. So to get the angular speed, you just multiply 2 pi times f and you get the answer. And then if you want the linear speed is r omega. So the radius of the winch is 25 centimeters. Convert that to meters times your omega and you get the answer. And then how long does it take? So you just use v as distance over time. Your distance is this 31 meters. That's your distance. And your time is what you have to find out. So time is distance divided by speed. So you got your linear speed and you get your answer. So once you've understood this, and maybe if you try working it out without looking at the working and then go back to check, and I hope this made sense. If you have any questions, just put that in the query sheet. So bye for now.